to talk about cloud computing and virtual machines. I never saw this slide before. Alright, so cloud computing is just basically a service that's provided over the internet. Usually involves some sort of like data center where people's data is kept online. And usually, like, it could be used by a business to keep all their data off-site, or it's used like something like iTunes or Steam. And a lot of times it'll be outsourced to a company that specializes in cloud computing. So like some sort of like a bank will keep their records in some sort of cloud computing company's website so that people can access it online at any time.
Okay. And there are 5 characteristics of something that is considered a cloud, as said by the textbook. There's self-service, which means you can access it from anywhere or at any time without having to talk to people, basically. Broad network access, that basically just means you can either access it over a network specific to your company or the internet, because iTunes exists, I think. Resource pooling, that means that the provider can have a bunch of customers all working on the same hardware at the same time using virtual machines or something, and they can reassign resources, like physical resources, between them without really having to worry about it. Elasticity, it means the same thing basically. Based on demands, the resources can be assigned dynamically. And measured service, it means they keep tabs on how much computing power and data storage you use, so they can charge you for it. And yeah, what is cloud? And then there's infrastructure as a service. What this basically means is that instead of providing you with software as a service, which all of you probably know about, they just provide you with like a blank virtual machine that you can put your own operating system on, load everything up on, you can do whatever you want to it. There's virtual machine monitors that are also known as hypervisors, and they can run multiple virtual machines all on the same hardware, so that a bunch of different people using the same cloud can all work on the same type of thing, or the same machine. And yeah, they can choose everything. Okay. I think that was it.
Okay. Virtual machine migration is when a virtual machine needs to move from one system to another system without it losing anything. So basically, it needs to like copy the entire RAM, everything that needs to run the system from one system to another. This can be like, if 2 people are using it like at the same, if somebody's accessing it and it's on one system and it needs to move while they're accessing it, that can be really slow because it needs to like stop and copy it. So this can cause a pause in its execution. This can be helped by seamless live migration, which can basically preemptively, every time something is written and one, it copies to both machines. Like I think when it's expecting it needs to switch. So that's called pre-copy memory migration. So basically, it does while in the background it copies the files that aren't currently being used, and it like flags those, and it flags the ones that have been changed while it was migrating. And so the pause is there's still a pause, but it only pauses for like a few things that were being used while it was migrating.
It copies the things that are currently being accessed. So if it's writing something, it'll also copy it at the same time.
Yeah, it flags it in the other system that those have been changed, and then it copies them. But all the other ones that were not accessed,
Oh, quick question. What are 2 of the characteristics of something that is a cloud? That was on a few slides ago.
You can access it anywhere, anytime.
That's true. Yes, over and over. Okay. Give him a cupcake. Gets a cupcake. Oh yeah, one more person. Yeah, I guess you can say the other characteristic. Anybody else? You get a cupcake.
Okay, another easy question.
Like the hardware.
I guess that's true. I don't know if that's specifically one of the characteristics, but give him a cupcake. Yeah, no, that's not it. He said specifically manage it yourself. It just means another company is for you.
What is it called when a virtual machine copies from one system to another while it's being accessed and the break isn't very long for you to access it, and it doesn't cause a noticeable break for the person accessing it?
You're talking about seamless live migration?
Yeah.
Sweet.
He didn't raise his hand. Give him a cupcake.
Oh, I'm sorry.
It's okay.
Try not to touch your icing here.
Want a cupcake so bad?
Oh, that's okay. Checkpointing is it's basically like while the virtual machine's running, it basically saves like a state of everything, and it's like it basically like if some error occurs later, you could go back to that save state. There's like a runnable state where you're good, so you can always go back to that if something occurs that messes it up. And the way this is done is it copies the files as they're written, and it creates a snapshot of running VM.
You can pause a virtual machine, which is one of the best things about it, because then you can, for very brief periods of time, you could say like pause a running machine, then turn it back to that state. And if you pause it for a long period of time, people will notice. So what they do is they copy only a few things at a time as they're going. So it's like very, very unnoticeable. That's what seamless live migration was. That's also how they do checkpointing. Same thing, kind of.
Okay, I'll be covering VMware and their software VMware workstation. VMware was founded in 1998. Their goals were to implement virtualization in the x86 architecture and to bring virtualization to the personal computer. And they did so in 1999 with a Type 2 hypervisor VMware workstation that ran on Linux and on Windows. There are 3 criteria for x86 virtualization's compatibility, performance, and isolation. Compatibility and performance basically meaning that you want the environment on the guest operating system to be similar or close enough to the same operating system running on the host architecture. But there were problems with implementation, one being that the x86 architecture isn't necessarily virtualizable because there are certain sections that are sensitive to virtualization instructions, and there are other parts that aren't. And there are too many I/O devices to account for to implement inside of the virtualized environment. There are 3 methods for VMware virtualization, which are trap and emulate, para-virtualization, and dynamic binary translation. Trap and emulate is essentially allowing the processes from the host operating system access the hardware itself, but as soon as a sensitive instruction comes about, it traps that instruction before it can be executed. The VMM emulates it, and then the execution continues to run on the virtual machine. Para-virtualization is, I'm trying to remember. I'll get back to that. Dynamic binary translation is pretty much pure emulation, in which it doesn't matter whether the instruction is sensitive or not sensitive. It's just emulated through the VMM and executed on the virtual machine. The VMware's VMM uses both trap and emulate and dynamic binary translation, which limits the overhead and allows the virtual operating system to run at low rate speeds. There is a feature called software fault isolation, in which they take memory and they basically create a 4 megabyte buffer between the information that's on the virtual machine and the VMM itself, so the actions that occur on the virtual machine don't interfere with the VMM, other virtual machines, or the host operating system that it's running. The VMware workstation essentially consists of these 3 roles: VMX, the VMX driver, and VMM. And I'm going to read this up. The VMX handles the user interface. It starts the virtual machine and performs device simulation. And there's 1 multi-thread VMX per virtual machine. The VMX driver is a kernel mode device driver. It's installed on the OS and it temporarily suspends instructions on the operating system to allow instructions on the VMM to run. And it's installed on the operating system during boot time. And the VMM contains software for the multiplexing in order to do exception handling, trap and emulate, dynamic binary translation, etc. It runs in the kernel, but it doesn't run in the operating system. And there's one VM instance for each virtual machine that's created when the virtual machine is being started. The virtual hardware consists of multiplexing, which I just covered, and emulation, which is essentially breaking up the virtual machine into a front end and a back end. The front end is essentially, it's mainly used related to hardware. You have different peripherals that you can place inside of your computer. And the front end in the virtual machine is essentially having a piece of software representing any peripheral that you can attach to your computer. And there is a driver, a specific driver for that virtualized hardware that represents your external hardware that doesn't have to be manipulated. And the back end, as it says, basically it just interacts with the host operating system. And the separation between the front end and the back end is known as hardware independent encapsulation, and it allows for migrating virtual machines from one machine to another without having to recreate instances of drivers, and you don't have to really set up the environment. It's just easy migration and seamless migration.
What is the front end?
Section of software that the user interacts with.
Yes. Okay. Great. What is the back end? Yes. What is okay, one more question. What's multiplexing?
I only have 2 hands.
Multiplexing? You already got one. Get out of here. You just have to read it, people.
It's the configuration of the hardware to be used directly by the virtual machine.
Yes.
Who is it? I don't even know.
How do people not want to come?
Okay, now, as with all technology, new technology comes in. So with VM, we